Assalamualaikum warahmatullahi wabarakatuh. Hi guys, how is it going? Welcome back to our group, and in this video we will discuss about vector. Before we get started, I will introduce you my teamwork. They are three people. First, it's me Azhara Muhaddifa, and then Nadiratul Husna, and the last is Sarah Rahayu. So guys, first we will understanding a vector. Definition of vector. Vector is a quantity that has value and direction. Vector can be described in the form of straight line that have length and direction. One of the benefits of vector mathematics in our life is the use of GPS or Global Positioning System. If you need direction to a place, you can rely on the GPS system from your cell phone. Well, this GPS will determine the location of your destination with the help of satellite. Without taking a long of time, you can immediately find the location. In addition, the GPS will also show direction to get to the location. So cool, right? So, what are the type of vector? The first type is unit vector. Unit vector is a vector that has a length of 1 unit. For example, we have a vector d, and vector d is 4 unit. So unit vector of vector d is 1 unit. And then zero vector. Zero vector is a vector that has 0 unit magnitude and uncertain direction. The direction of zero vector is 0. So guys, that's all of from me. The next topic we'll discuss with Sarah Rahayu.
Thanks to the moderator, I will continue the topic that is possession vector. Possession vector is a vector which is the possession of the particle to a certain reference point. We can see that at the beginning, the central point O, the point 0 and 0, and point P, the point x1 and y1. Basic vector. Basic vector is a vector whose length is 1 unit, but its direction is the same direction as the coordinate axis, with point J, 0 and 1, and with point I, 1 and 0. Length of vector and vector operation. Length of vector. The length of a vector is a length of the line segment representing the vector. The length of vector AB is denoted by vector A, B. Topic: the vector length on the plane. If known one point A of XA and YA, vector A equal square root of XA powers of 2 plus YA powers of 2 if known to point A of XA and YA and point B XB and YB. Vector AB equals square root of XA minus XB powers of 2 plus YA minus YB powers of 2. For the next topic will be explained by Nadira.
Thanks before, we will continue to the next topic, vector operation on plane. The first operation, adding two vectors in a triangular way. We have two vectors, A vector and B vector. A vector plus B vector, basically we call R vector. R vector connecting head from A vector to the tail of B vector. So in this condition, we have to remember head to tail rule. Then head from A vector to the tail of B vector, and the direction from a head of A vector to the tail of B vector we call R vector. And the second operation on plane, that adding of two vectors using a parallelogram. We have two vectors, that A vector and B vector, and we have a parallelogram. We make the diagonal from the parallelogram, that is the R vector. So R vector is a vector plus B vector. The next is the vector formula from the sum of the result PF the parallelogram method. From the illustration beside, we have to look at A vector and B vector and R vector. And R vector is A vector plus B vector. So the formula is absolute value from A vector plus B vector equals to square root from absolute value from A vector square plus absolute value from B vector square plus 2 times absolute value from A vector times absolute value from B vector and times cos theta. And for the subtraction, that A absolute value from A vector negative absolute value from B vector equals to square root absolute value from A vector square plus absolute value of B vector square negative 2 times absolute value from A vector times absolute value from B vector times cos theta. So now we will discuss about the example from vector operation. The first example is, it is now B point then negative 4.1. Find the coordinates of point A if AB negative 6 and negative 5. The answer is AB vector equals to OB vector negative OA vector. So we can looking for that AB vector equals to B vector negative A vector. And we can move A vector to the left, that A vector equals to B vector negative AB vector. A vector equals to negative 4.1 subtract 2, negative 6 and negative 5. So we have that A vector equals to negative 4 plus 6 and 1 plus 5. So the result from A vector is 2 and 6. The second example, given the vector A equals to negative 3 and negative 4 and B is that negative 5 and 1. Define absolute value from A and the absolute value from B. The answer is absolute value from A vector equals to square root x squared plus y squared equals to square root from negative 3 squared plus negative 4 squared equals to square root 9 plus 16, that equals to square root 25. The square root of 25, that 5. So the result from absolute value from A vector is 5. The next step, we have to looking for the absolute value of B vector. The absolute value from B vector equals to square root x squared plus y squared equals to the square root from negative 5 squared plus 1 squared equals to square root from 25 plus 1. So the result is equals to square root of 26. So the answer is the absolute value from A vector is 5 and the absolute value from B vector is square root of 26. That's all our presentation today. Thanks for watching. Don't forget to like, comment, and subscribe. And last I say Assalamualaikum warahmatullahi wabarakatuh.